Hello everyone. Hi, my name is George. Thank you for having me in this great conference. So today we're going to talk about how to hide some sensitive information within plain sight within our Android applications. So let's take a look at that. First of all, let me begin by introducing myself. As I said, my name is George Kortsaridis. I'm living currently in London and I'm working as an Android software engineer for the Amazon Ring team. Alright, so the agenda for today is I'm just going to split my talk within two sections. First is going to be the offense part, where we're actually going to reverse engineer a real-life application, and we're going to see pretty much everything that there is to see within the application. And then we're going to talk about the defense, and we're going to talk about how we can make our applications a little bit more hard to crack, or how we can hide some stuff a little bit, better within it. So let's start with the offense. Before we actually get to reverse engineer the application, let's begin by talking about what there is to hide within the application. So first, of course, the first and foremost is the source code, is any type of Java or Kotlin code that we are writing as developers. Apart from that, there's the resources, so any strings, layouts, images, fonts, anything that you might add within the resources of your applications is also there to hide. And then, of course, there are also any extra modules that we might be using apart from the app module. There is any third-party libraries that we're using within our application. Either they might be ours or any third-party downloads from the world. So all of those three things are not safe within our applications. They can be reverse engineered, they can be hacked, and they can be plainly found, as I will show you later on. Next up, let's talk about some motivations behind the app reverse engineering. So why would somebody do that? So first and foremost, of course, there are some people that do that to steal or leak some information from your application, either to disrupt some services. There are, of course, financial gains involved in that, and then there are some people that are doing it for any sort of hacktivism purpose. On top of that, which can be categorized as some bad reverse engineering, there's also the reverse engineering for good as well. So people can reverse engineer your application in terms of security audits. So there are actually, or bug bounties. So there are actually people who are getting paid to make sure that your application can either be reverse engineered and not give out any sort of important information that you want to hide, or not information at all. So reverse engineering is not always bad. Great, so now before we actually get to reverse engineer application, let's talk about how we go from your actual source code to the production APK, how the application is built. So first and foremost, we're having the manifest, resources, assets, and source codes. And of course, any of the libraries that we're using. So the first step is that the manifest, the resources, and the assets are being packaged together into the packaged resources that are called AAPT. Then our own source code and the source code of the libraries that we're using, so any third-party libraries or any extra modules, those two are being bundled together into the bytecode. So that is creating a file called classes.dex. And then the packaged resources and the bytecode gets packaged together again into the unsigned APK. And this is the APK that is fully executable, and this is what we're using when we're developing our application. And then, of course, in order to publish this APK into the Play Store or into the world, we need, of course, to actually sign our APK with a key. And the key is a really important part in all of this procedure, because it's the only thing that stays within our own reach. It's not given out to the world. So we're signing our unsigned APK with that key, and then we have, of course, the signed APK that's ready to go to Google Play Store or anywhere else that we want to distribute it. Nice. So now let's talk about the actual offense part. We're going to see the application that is on the right of the screen. It's going to be a really simple application with two screens, as we're going to see in a little bit. And that application is going to have a small secret that we'll need to figure out. So without further ado, let me open the screen of my phone and show you the application. So this is it. This is the first screen of the application. As you can see, we have an image, we have two texts and a button. the button goes to the next activity. And pretty much this is where it gets interesting, because as you can read, it says below is my secret key, but you cannot see it. So right here, there must be some sort of text that we need to figure out what actually saying. So let's do that. In order to do it, I will actually open the Visual Studio Code, and I will do all of that using a single VS Code extension called APK Lab. This is the simplest way I found so far to just do everything at once with a simple click. You can either do it on different steps using command line, or there are also other online free or paid resources and tools to do the same thing. But for me, what works is that sort of extension, and it is by far, in terms of my experience, the simplest way of doing it. So pretty much once we have the extension installed in our VS Code, the only thing I'm going to do is I'm going to do Shift Command and P, and I'm going to select the APK Lab, open an APK option. And after that, I am going to use the application that I have already generated or downloaded from the internet. This is the APK from the application that I just showed you. And I will, of course, select this APK file, and I will get some options here. So what I want to do is I want to get the main classes, and I also want to decompile the APK to Java using the JADX. So once that's happening, I'm clicking OK, and as you can see in the bottom of my screen, there are some tools that are actually being run right now. One is the APK tool, and then is the JADX. And once all of those are done, okay, so now that's done, we are actually going to have a new VS Code folder with everything included. So let's actually get to work, and let's see what was the outcome of what we just did so far. We will first open a manifest folder, a manifest file. So in the manifest file, as you can see, it is pretty familiar for us, the Android developers. We can see that we have an application tag and then two activity tags. That also confirms that we're just two screens, so two activities that we need to go through this application. And as we can see, the main activity is the launcher application. So that's good. And then the second page must be the secret activity. Now let's move forward and go into the resources folder, the res folder. So in the res folder, as you can see, we can get pretty much, as I mentioned before, all of the resources that we packaged in our application. So there are animations, there are colors, drawables. So for drawables, let's say, if I open that folder, you're going to see that there are many drawable items that were added by the Android OS, but as you can see, I added one PNG within my application, and that PNG is here, full screen solution, and I can get it as easy as that. Now, if I want to do something different, I will go into the layout. And again, of course, there are multiple layout files here, but what we are currently interested is the activity main and the activity secret. So opening the activity main first, as you can see, again, is something really familiar to Android developers. We're having a relative layout with a linear layout inside, and then an image view, two texts, and a button. As simple as that. Now opening activity secret, again, we're having a linear layout, and inside we can see two texts, so it pretty much confirms what the application said before. One text is that below is my secret key, but you cannot see it. And then on the second text, we can see that we couldn't see it because the color was white. It was the same color as the background, so it makes sense that we could not see it. But when we go into the actual text, we see that this was just a placeholder for the hidden message. So that means that we need to continue digging up a little bit and go furthermore. So let's close the layout folder and continue with the values folder. And within the values folder, what I did is I'm going to open the strings file. So again, you can see there are many strings that are added from the Android OS, but what I am most interested is those top 3 strings. Just for simplicity, it was me who added the 2 underscores, just so everything is on the top when we decompile it. But what I wanted to show you is that if you thought that, I'm just going to add any string that is important to me in my strings file and it's going to be safe and easy, it's not. because as you can see, all of my strings here, all of my hard coding strings are pretty simple and pretty easy to find out within the decompilation process. And then of course there are multiple values folder for different locales, and that would sum up all of the resources folder. Now, of course, what we're more interested in is the sources folder. So we're gonna open the Java source folder, and we're gonna see that we have the Android subfolder, Android X subfolder, COM and Kotlin subfolder. All of those subfolders were added by the OS. But of course, there is the actual subfolder that we're interested in, which is the actual source code of my own application. So we can see that we have some files here that were decompiled. We have, of course, the constants. And in the constants, it's something that seems interesting because we have an encryption key that was also hard-coded, and it's right here. We have an access key and we have an AWS secret key. And we can see that there are some getters for those variables as well. And then of course we have the main activity, and in the main activity we can see that it extends the appcompat activity, and then there are some methods. We have the get stuff from the internet, which just returns a string, so we're not really interested in that. We have onCreate that just sets the content view into the activity that we showed before, the XML activity, the layout. We're running the get stuff from internet, which doesn't do much stuff, so it was probably just to throw us off. We're logging something, and then we're logging the encrypt something important. And if we go down here, we're gonna see that the encrypt something important just uses the strings.reverse, and then it reverses the string that was given as input. So pretty much the encrypt just reverses what gives out. So not really safe encryption, let's say. And let's move further on, and we can see that there is the button here with an onClick listener, and then the onClick listener calls the lambda, and the lambda just starts the activity of the secret class. So let's move into the secret class, and right here is what we were searching all along. We can see that the hidden message was getting the text, was setting the text from the constants.get AWS secret key. So the contents AWS secret key is this value right here. So this is what was actually shown in our application. This is what we were trying to hide. So that was, as you can understand, that was a pretty simple case of decompiling an application, but it pretty much combined a lot of things that usually when we're developing an application, we're just putting them out there, just putting them in the app, thinking that they might be safe. Okay, so now let's move on, and let me open my presentation again. And let's proceed with the defense part. So we saw that pretty much any APK can be reverse engineered, can be hacked. Now let's see what we can do in order to make our application a little bit harder to crack, how we can hide some of this information a little bit furthermore. So I'm going to go on a case-by-case basis, and we're going to talk about how we can do some stuff in each case to make our applications a little bit better. So first case would be for any of our applications that are using real-time GPS position. So any type of location using within our application. For this thing, so there are so many free and paid applications that are just mocking the device's location. And the simplest way for us to just check if the application is mocked within our app, it's just actually checking if the mock locationing is enabled or disabled with your application, and then act accordingly on that. So that is one thing that you could do if your application uses location data or is handled by location data in any case. Next up, it's something that I want to pretty much say on every single time I have the option, is that we always need to act based on all of the HTTP responses. So usually what's happening is that when we're having an HTTP call, we are checking for the successful response. So if everything is okay, then continue with our flow, with our application flow, or else then just show an error message or try again or something similar. That is not the safest way we can do it, and the reason for that is that because there are so many tools that hackers and attackers can use to pretty much check what our applications are taking and check what we are expecting to receive, and then tweak this information. So, of course, if we're relying on the web, then that would mess up our own application. So we should always start looking more and more into any unauthorized access within our application, and by unauthorized access we would that would be an expired token, or a request without a token at all, or any type of unauthorized access that you want to actually build into that, and then you should always act based on that. So if there is an expired or no token, you could either just display a message and sign out the user, or maybe even go all the way to blacklist that MAC address, so that MAC address never gets any responses. It always depends on what is the level of security that you want to add within your application, but the most important thing that you should always remember is that you need to act based on all of the error responses, and not just using an if success do stuff, else do nothing. Moving on, let's talk about local storage. So, of course, local storage is for stuff that are actually happening on runtime. If we want to save something on runtime, what are we doing then? We're having, of course, multiple options for storages, and the first thing that we're going to talk about is the shared preferences and the external storage. As you can probably imagine, this is not the safest way to store any of your files, because anything that's stored there is not encrypted, and it's again plain and easy for anybody to just access. So if there are some options that I would like to recommend, there is that you should not store any credentials there, you should not store any certificates there, of course you should not store any encryption keys, because if you're using a really strong encryption method and then you're storing the encryption keys somewhere that's not safe, you're pretty much giving out the key to anyone. So your encryption method is pretty much useless. So never store encryption keys on shared preferences or external storage. And of course, you should not be storing any device information such as serial numbers or name or anything like that. You could be storing those stuff that are not secure. So things like settings, or things that it's okay for any attacker to pretty much find out. Next, we're having the encrypted shared preferences. That is actually a place that you can store valuable stuff. So encrypted shared preferences, of course, are always, as the name suggests, encrypted by separate keys. And in each of those encrypted shared preferences buckets, you could be storing confidential data, you could be storing tokens or refresh tokens, and anything else like that. Some things that you should always be mindful is, of course, that you should be using a different ESP file. The ESP file is the actual encrypted shared preference file. You should be using different ESP files for each of the valuable items that you want to store, or each of the categories of the valuable items that you want to store. And of course, each of the ESP files should be having a different master key, which is of course really important, because if one ESP file is decrypted, you could not be decrypt the same, the rest of the ESP files with the same master key. And of course, we should be speaking about the key store. The key store is pretty much a place within the Android application that all of the encryption key materials should be stored in. And of course, in order to access the key store is given to us by the Google operating system. And of course, anytime we're accessing the key store, we should be using either biometric authentication or the highest form of authentication that the actual device is giving to our disposal. And of course, there are some other stuff. So for example, we should always be requiring the highest security level supported by the OS version, or we should be using the set unlock device required for critical and highly confidential and restricted data. Alright, so let's continue talking. So let's talk about the NDK. Let's talk about how we can add something extra into our application. As you might know, we can use some native coding within our Java applications with C or C++ that get bundled within our application as well. Now, I'm not going to say that hard coding your key within the NDK is safe, because the NDK files can also be decompiled and can also be found out. But if you have to hard code something, it might be better to use the NDK, because it just adds an extra step into the whole process. And of course, it just adds a little bit more difficulty, and it's just a useful tip of instead just hard coding stuff into your Java files. Now let's talk about the APK signature check. So as I said before, in the process of creating our APK ready for the world, we are signing it with our own key. Now the key is really important because it's the only thing that stays within our own reach, and it's not bundled within the application. So pretty much what's happening is that when we're signing the key, we're being faced with something like this that you see on the screen, and we need to set up the key aliases, the passwords, and everything. Now that creates a hash, the signature hash, and that we can have it within our own key and store it somewhere safe. Then, anytime we run, we can always check if the application that's currently running is signed with the same hash as our own key. Why we're doing that? Because some hackers can take our application, they can disassemble it, they can reverse engineer it, they can change something, they can tweak it. But in order to send it back to the world, they need to sign it again, and they will sign it with their own key. So pretty much what we need to do is we need to check whether the current signature, the current hash, matches what we expect to. Again, it's not something that cannot be reverse engineered, cannot be tweaked, but again, it adds an extra step, some extra difficulty into an attacker. And then, of course, if you have something that's really important, let's say an algorithm or like a piece of code that you're really it's really important that people do not get their hands on, then just don't put it into your application. Just hide it into the backend. You can abstract it, so your application just uses it as an HTTP call. That is much safer and much simpler, because it's not bundled within the application that you should always be mindful that lives into the hacker's device. So it's up to the hacker's limits. And of course, I need to close by saying that all of what I just said relies on a secure operating system. What that means is that, again, just because all of our applications are running on the hacker's devices, the hacker's device can be rooted, or the breaking down can go up to terrific levels, pretty much. All of those things that I just mentioned can mean nothing if the device that our application runs is not secure. So you should always have that in mind. And pretty much what I'm going to close with is that I want to remind you that all of that I just said are just ideas to add a little bit more time and difficulty into an attacker to reverse engineer your application. Any attacker with enough determination, enough financial resources and time, they can and they will access any intended data or code. So you should always have that in mind, and you should have a threat model and develop your application with remediations necessary to accomplish your goals. This is a really important thing, that if there's one thing that you should leave out with from this talk, is that one. So that was it from me. Thank you really much, and I'm looking forward to getting any questions on my email or on my Twitter handle from any one of you, and have a great day.